So welcome you all for the today's session. The session topic is smart antennas. Myself, Dr. Prasanna, Professor in Department of Electronics and Telecommunication, YCC. Now, so smart antennas are the antenna array with the smart processing algorithm that identify the spatial signal signature with the help of direction of arrival, and with the help of that we calculate the beam forming vectors that has to be tracked for desired users. Smart antenna, it uses the diversity effect at both transmitter as well as receiver end. These antennas, also known as the adaptive array antenna, or we can say the MIMO, multiple input, multiple output. When we use the direct diversity effect, it not only increases the data rate but also it decreases the error while transmitting signal from source to destination. Presentation begins with why the smart antenna, what is smart antenna, and how it works, that we have to see. When the system is non-smart antenna, of course earlier the base station antennas are omnidirectional antennas, and it has a, these are the limitations. Its capacity is limited. There is a more interference, but that can be overcome by means of the sectorized antenna. Here we have to make the predefined antenna, and accordingly a beam will be active only in a particular direction when it is required. So why it is the smart, we use the smart antenna, it has a many advantages, like as compared to the classical system or traditional system. Greater coverage area, we will get better rejection of co-channel interference, reduce multipath interference, increase data rate and overall system capacity, handset battery life is extended, track multiple users, reduction in power, reduction in drop calls, increased frequency reuse with the less base station, and location information in case of emergency situations. Smart antennas classification, it is in the switch beam antenna and adaptive array antenna. These are the further types, that is single beam directional antenna, multi beam directional antenna, single user and multi user beam forming. Basically, this adaptive array system is nothing but the smart antenna. So adaptive array, which allows to steer the beam to the direction of interest while simultaneously nulling the interfering signal. Beam direction can be estimated using direction of arrival algorithm, and this can be possible by means of DSP processor. Once the beam is formed with the help of different classification, then we have to steer the beam, and that can be possible by means of the algorithm with the help of DSP processor. These are the different switching systems that we already seen. So in the sectorized or switch beam system, these are all the predefined uh, beams, and users only get the signal in that particular direction, and if user is here the beam is active, if this is user 2, but in between it cannot get the signal, and it has a fixed capacity. For example, these are the three axes, if you see, with a degree of 120, and this is the capacity of 120 user, this is the capacity, sector capacity is 120, this is 120, total 360 degree, and let us say 360 users can work together in the sectorized system. But if there is a, suppose 200 users are coming in particular direction, that time this signal will not received by all 300 people or users, and therefore this is the limited capacity, because its capacity is only a 120. So in this single, only one beam is active in the single beam directional antenna, and the multi beam is active in the multiple directional antenna. This is the smart antenna analogy with the human. This is the human. If the this is the desired speaker and this is the undesired speaker. If signal is coming from both the side, then the ear cannot identify the which one is desired and which one is undesired. But the same system, it can easily identify by means of, we can say, the phase array with the DSP processor. For example, here user number 1, when it sends the signal towards the array, it will get the direction of arrival 1, and here is the unwanted speaker direction of arrival 2. So with this adjusting the DSP processor, it adjusts the phases of the phase shifter. Accordingly, it will focus the beam only in the desired direction and it gives the zero or null in the undesired direction. So it reduces the interference in the system. Or we can say, if the one person is speaking in this direction, we can change our face in that particular direction. If the other person is in the other direction, then we have to change the direction, and accordingly it will work. This is the smart antenna. It's a cellular system with the radio communication between the base station and the mobile phones based, and all these things. Just go through it. Will experience interference by the user, the power radiated. So what will happen here? In this, the power is radiated throughout the time, whether user is present or absent, irrespective of that. Whereas in the smart antenna, it focuses the beam in a particular direction. If there is a user, if there is no user, beam will be not focused in that particular direction. So this is the, we can say, the phase array with a predefined beams are there. Okay, and this is the adaptive array. In this adaptive array, we may say the change in the beam pattern according to the movement of a desired users and the movement of an interference. The signal that are received be the weighted and latter combined to increase the wanted signal to interference in addition to the noise and the power ratio. The antenna beam can easily be steered the main beam to any direction while at the same time nullifying the interference of a system. The direction of a beam can be calculated using the direction of arrival method, and it will focus in that particular direction. In adaptive array antenna, if these are the different multi array antenna, and these are the phase shifters that can be easily controlled with the help of DSP processor. And a single beam user beam is used to track user, and the single transducer is used in multi-user tracking different beam patterns, and it will track. There is a tracking system is there, if the, and accordingly it will focus the desired beam in that direction, which is somewhat difficult in the simple array system. For example, this is a switch beam, this is desired direction user 1, and this is user 2. These are the interference, but beam is also focused in that direction, which we can avoid in case of the adaptive array system, that is the smart antenna. User, it will focus, but interference 1 and 2, here it focuses the null, and that is the advantage. If you compare these two systems, you can see that the low interference environment and the significant or high interference environment, and of course the gain is in both the cases are equal in adaptive array system. Switch beam is little bit work properly in the low interference environment, whereas which is very less as compared to this in this high, we can say, significant interference environment. And conventional sectorization is also somewhat more in this case, whereas which is very small in the that is high interference environment. Switch beam array, the less coverage and the low interference rejection, whereas adaptive array is a reduction in the transmitted power, more coverage and high interference rejection. That is the adaptive array, and this is the switch beam array. So they uses these techniques, the FDMA, there is frequency division multiplexing, time division multiplexing as multiple access, CDMA, that is code division multiple access, and in smart antenna we use SDMA, that is the space division multiple access. Smart antenna are the base station antennas with a pattern that is not fixed but adapts the current radio conditions or environment, and this can be visualized as the antenna directing the beam towards the desired users only, whereas in the undesired or interference it use the null, and that is the advantage. If you use the capacity will be increased in 3 times in the TDMA, whereas in the 5 times in the CDMA. The drawbacks of this system is it increases the transceiver complexity, and therefore the cost will increase, and therefore the radio resource management is complex. So the smart antenna consists of number of radiating elements, means antennas, phase shifters, combining and dividing networks, control unit. We call as the smart antenna intelligence digital signal processing. This block is very important. This DSP processor is present in case of adaptive array system, and in only phase array system it will not present. That is the difference. See, this is the way. If this is the desired user, it focuses the beam only in that direction, whereas in undesired user or interference user, it focuses the null. It uses the SDMA, that is the spatial processing digital beamforming adaptive antenna system, and the smart antenna system are customarily categorized, however, as either switch beam or adaptive array system. These are not popularly used, but adaptive array phase is more important. This is a simple smart antenna system. That is, there is the direction of arrival estimation. This is the beam forming. These are the phase shifters. We can change the weight, okay, with changing the magnitude of a phase shifter, and we can get the output from this, or it will focus the beam in a particular direction. This is the adaptive array system. Difference is that here we use the adaptive algorithm, or we may say this adaptive algorithm is DSP processor, we can call as, and it will give the adjust the phase shift of individual antenna element, and accordingly beam can steer in any direction whichever is the desired one. And this is the output, and here is the error signal, and this is the reference signal, and accordingly there is a feedback, and it will control continuously track the multiple users. Adaptive array system, the phase array antenna made up of the multiple antenna elements. Each radiating elements we are connected to the phase shifter to provide a phase shift of each radiating element. If we know that the phase angle psi is equal to beta into d cos theta plus alpha, where beta is nothing but twice pi by lambda, d is the distance between the two antenna element, and alpha is the initial phase. With varying the frequency, or we can say phase, and we can with this physical distance we can steer the beam any desired direction. Even alpha is equal to 0, it steers the beam in a particular direction, and when alpha is going to be vary, the individual antenna element alpha, that is phase shifter, is changing. Let's take, if there is a three phase array, then alpha 1, alpha 2, alpha 3, and if alpha is are different, it can focus the beam simultaneously only in the desired direction without changing the physical structure. If you want to change the steer the beam, the alpha, that is the initial phase, we can adjust, and accordingly it can change the beam. See this figure, that is illustration of a smart antenna. So it will beam will be focused as per the user direction. This will happen only in the smart antenna, that is adaptive phase array antenna. This is the basic, this is the multiple elements, these are the phase shifters. We can change the weight W1, W2, W3, and this is can be possible by means of adaptive algorithm. This is beam forming signal we can get. This is the reference one, as I told, and it will focus in that direction, desired direction beam, and undesired direction it focuses the null. So advantage that it uses the direction of arrival algorithm. Then tracking, it uses continuous tracking, minimizing the interference signal, and signal to noise ratio is quite high. These are the beam, it should focus in a particular direction. With changing the phase, we can steer the beam to the desired direction, or in this direction. It can steer the beam throughout 360 degree, we can say. Applications: acoustic signal processing, tracking of radar, radio telescope, cellular system, and radio astronomy. These are the applications. If there is a multiple users, it can easily fulfill our conditions. Beam focuses only in a particular direction. This is the way. This can be possible. These are the antennas, okay, base station antennas. If you are in a car, it looks like this. You can see very easily this type of antennas on the rooftop, okay, and it will be the sectorized antenna. It will focus the beam with a particular array is formed, and it will focus the beam in the desired direction only. If you look this figure, these are the horizontal beam forming, and this is the vertical beam forming.